In this video, I want to go over some common functions that are used in engineering. These are all functions you've probably been exposed to before, but we use them pretty commonly, and so have a couple of lectures set aside to look at that. Some resources, and these are from all over. Let me enlarge the screen here. Obviously, Wikipedia and Khan Academy are both very good, and so if there are any things or items that we go over in the video today where you feel like you need more extensive background, then I would certainly recommend or refer to some of these resources. I also want to credit that some of the figures, etc., that I've taken have come from Wikipedia's site. So the first thing to discuss is polynomials. Polynomials are found often in engineering. As a general rule, the polynomial has the following form, where we have some constant coefficients that then multiply the variable raised to a power. N is always, in the true sense of a polynomial function, n is always an integer or zero. And so polynomials traditionally are written in descending order, where you start with the highest order or the highest value of n, and then you write it until you reach the constant in descending order of power. That's just a convention. It doesn't mean anything mathematically. So the a's are constants, and they're referred to as coefficients, and they can be 1 and they can also be 0. The highest power of x in this case is n. So this is referred to as an nth order polynomial, or a polynomial of the nth degree. A polynomial of order n will have n roots, or n values for which the polynomial is equal to 0. The roots can be 0, they can be a real number, or they can be a complex conjugate pair. It is possible for roots to be repeated, in which case they're referred to as repeated roots, or second order roots, or so on. An odd order polynomial will have at least one real root. So how do we find polynomial roots? You can go to great extent in mathematics classes and algebra classes to figure out how to factor polynomials of third order. You get much higher than third order, and unless they're a special polynomial, you're just not going to be able to factor that by hand. So in this class, part of what we want to do is discover new and different ways to use MATLAB. So we'll use MATLAB to find the roots of the polynomial. So for example, if you consider the polynomial 3x cubed plus 2x plus 4, how would we find the roots of that in MATLAB? Well, first of all, if you go to the MATLAB workspace, you can define a function f using the square brackets. And notice that what we have here are the coefficients of the polynomial terms in descending order. And notice that in the polynomial we have no x squared term, so we have to put the 0 in here as a placeholder for x squared. So the way MATLAB interprets this is it interprets this as 3x cubed plus 0x squared plus 2x plus 4. And so now then what you do is into the MATLAB workspace you type roots of f, and MATLAB will return the roots. So to end the video, let me just show you what we had in MATLAB. So here is our entry of 3024, and then we type roots of f, and so what we have then is we have the roots given to us by MATLAB. So if you wanted to factor this polynomial, what you would do is you would write this as a product of x minus the roots. So we would have x minus this root multiplied by x minus this root multiplied by x minus this root. And notice the complex term here. Remember, I is the square root of -1. And so this particular polynomial has 2 complex roots and 1 real root. So once again, just to fill in what we just said, once you have the MATLAB output, if you want to, you can factor the equation. So First, you factor the constant coefficient of highest order polynomial. In this case, notice that's 3, so let's go back. If you notice here, this x cubed has a coefficient of 3. MATLAB understands that this is factored out as a constant, and then MATLAB factors the remaining part of the polynomial. So we pull that 3 out, and then we just insert the roots. So this is x minus the first root, x minus the second root, x minus the third root. Now this is going to be important when we discuss partial fraction expansion. Partial fraction expansion is a way to write polynomials that are rational functions as products. So I will end the video here and let you do some practice on MATLAB with finding roots of polynomials.